Hi, I'm Sarah Ames,
And I'm Caroline Yates.
and this is our project on designing a hand warmer. The concepts applied in this lab are enthalpy change, calorimetry, heat of solution, specific heat, exothermic and endothermic reactions, and systems and surroundings. Enthalpy change is the change of the internal heat content of the system. Heat of solution means the same thing but applies specifically to solutions. The enthalpy change of the reaction will be measured and calculated using a process known as calorimetry. Specific heat is a variable used in calculating enthalpy change. The only specific heat value used in the lab is the specific heat value for water, which is 4.18 joules per grams times Celsius.
Endothermic reactions absorb heat and have a positive enthalpy change. Exothermic reactions release heat and have a negative enthalpy change. In order to develop a successful hand warmer, we will be looking for solids that produce an exothermic reaction, meaning they produce heat. In thermochemistry, the system is the part of the reaction that is studied, while the surroundings applies to the rest of the world outside of the system.
Hand warmers are made by placing packets of water and a solid within an external pouch. They are activated when the packets are broken, mixing the water and solid, creating an exothermic reaction. The greater the exothermic reaction, the more heat produced, and therefore the more effective the hand warmer. Calorimeters can be used to measure the enthalpy of a reaction while limiting the heat lost as the reaction runs. By multiplying the mass of the solid with the specific heat of water and the change in temperature, the heat of the solution can be found. This information can later be used to find the calorimeter constant, heat of the calorimeter, and overall enthalpy of the reaction.
The objective of this lab is to find the most effective, environmentally friendly, and cost-efficient solid to use in a hand warmer. The experiment will be carried out using calorimetry, comparing the change in enthalpy of each solid when mixed with water, then evaluating based on the cost of each solid and its impact on the environment. Ideally, the chosen solid should produce the most heat when mixed with water, have a reasonably low cost, and have a minimal impact on the environment. The solids that will be compared are ammonium chloride, calcium chloride, lithium chloride, sodium acetate, sodium carbonate, and sodium chloride.
Our hypothesis is that calcium chloride should be the most effective hand warmer because it has a reasonable cost and is expected to have a comparatively high output of heat. Calcium chloride is commonly used as road salt during the winter to prevent ice buildup on roads. Because of its ability to somewhat melt ice, it should be the most effective hand warmer.
In the first step of the experiment, we measured 100 milliliters of distilled water in a graduated cylinder, and then added it to the calorimeter and measured the initial temperature. We then measured 250 milliliters of distilled water in a beaker and heated it to approximately 67 degrees Celsius. Then added it to the calorimeter, monitoring the temperature change. Using the initial temperature and the final temperature, we calculated the heat of water and used this value to find the heat absorbed by the calorimeter and the calorimeter constant. We then had to find the change in enthalpy of each solid. To do this, we measured 100 milliliters of distilled water with a graduated cylinder, then added it to the calorimeter. About 5 grams of magnesium sulfate was obtained and massed in a weighboat using an electronic balance. The initial temperature of the water in the calorimeter was then recorded. We poured the solid into the calorimeter while stirring and monitoring the temperature. The final temperature, the point where the temperature stopped changing, was recorded. Using the mass and temperature values, we calculated the heat of the mixture. This process was repeated for each of the 6 solids.
These are the equations used to calculate Q, the calorimeter constant, the heat of the calorimeter, and enthalpy. Q aqueous, or heat of the mixture, is found by multiplying the mass of the solid by the specific heat of water and the change in temperature. The calorimeter constant is found by dividing the heat of the calorimeter by the temperature of the mixture minus the initial temperature of the water. The heat of the calorimeter is found by multiplying the change in temperature in degrees Celsius by the calorimeter constant. The heat of solution is found by subtracting the heat of the calorimeter from the heat of the mixture and multiplying by -1. And the change in enthalpy is found by dividing the heat of solution by moles of solid. When mixed with water, some solids created endothermic reactions, while others created exothermic reactions. Because hand warmers rely on exothermic reactions to produce heat, the ones that created endothermic reactions, ammonium chloride and sodium chloride, were immediately discarded. Looking at the enthalpy values on the chart, the solids with positive enthalpies were endothermic reactions, and the solids with negative enthalpies were exothermic. The solids with more negative enthalpies were most effective.
This chart shows the prices of each solid in dollars per gram. To find the most cost-effective solid, the prices of each solid were compared with their respective enthalpies. Solids such as lithium chloride at 62 cents per gram and sodium acetate at 27 cents per gram were eliminated because of their comparatively high cost.
All of the solids used only posed either a level 1 or level 2 health concern. The health concerns of ammonium chloride are that it is a moderate skin and eye irritant and may cause harm if ingested and may cause asthma-like symptoms if inhaled. There are no major environmental impacts of ammonium chloride. The health concerns of calcium chloride are that it may cause serious irritation or burns if in contact with skin while wet, and it may be harmful if ingested or inhaled. The environmental concerns of calcium chloride are that it may have a moderate negative impact on water quality and a low negative impact on soil. The health concerns of lithium chloride are that it is a skin and eye irritant and may be harmful if inhaled or ingested in large quantities. The environmental concerns of lithium chloride are that it may have minor negative impacts on water. The health concerns of sodium acetate are that it is a minor skin and eye irritant and may cause harm if inhaled or ingested. There are no major environmental concerns of sodium acetate. The health concerns of sodium carbonate are that it is a moderate eye irritant, a minor skin irritant, and may cause harm if inhaled or ingested. There are no major environmental concerns of sodium carbonate. The health concerns of sodium chloride are that it is an extremely minor skin or eye irritant, and there are no major environmental concerns of sodium chloride. In general, lithium chloride and calcium chloride have the biggest safety issues as they both pose health concerns and environmental concerns.
From the experimental data, the solids with the most negative enthalpy, lowest cost, and least amount of safety concerns could be determined. The solids with the most negative enthalpies are calcium chloride with an enthalpy of negative 67.7 kilojoules per mole, lithium chloride with an enthalpy of negative 37.9 kilojoules per mole, and sodium carbonate with an enthalpy of negative 27.2 kilojoules per mole. The top three cheapest solids are sodium chloride, sodium carbonate, and calcium chloride. The solid with the most negative human or environmental impacts was calcium chloride. Due to the danger of contact with skin or the environment, the solid was eliminated in case the hand warmer were to tear open. The solid with the best combination of price, enthalpy, and safety for the hand warmer is sodium carbonate. Our hypothesis was incorrect due to the safety hazards of calcium chloride.
In finding the calorimeter constant, we lost too much heat during the heat transfer from the heating plate to the calorimeter. This raised the overall difference between our mixture temperature and average temperature. The loss of heat resulted in our extremely high calorimeter constant of 52.73 joules, while it was supposed to be in the high teens. This value worked as constant for our experiment due to the temperature at which it was conducted, but was very far off from the accepted value.
In the future, this lab can be further and better explored by improving the type of calorimeter used so that there is not such a significant amount of heat lost, exploring what type of material is an effective insulator for the solution, or finding what type of material is most tear resistant. By finding a tear-resistant external casing, calcium chloride could be used as a solid inside, making the hand warmer safer and more effective.
The sources we used for our lab were the AP Chemistry textbook and the lab packet by Flynn Scientific.
Thanks for watching our presentation.